Hey, welcome back to another episode of Sound Strategies. This week I'm sharing another experiment with you guys. I've got a test for EQ, and allegedly it's supposed to detect the amount of phase distortion that digital EQs imbibe onto the signal. So let's check it out. For this test, we'll start with a piece of audio and we'll duplicate it onto a second track. The first track is our dry reference, and the second, our wet comparison. Our first step is to flip the phase of the second track, the wet one. By inverting the phase of the duplicate track, we will hear nothing. The two identical signals are completely 180 degrees out of phase and will cancel each other out completely. The resulting silence will only be broken if a difference between the two signals occurs. Next, we'll add an EQ with a boost to the wet track. We'll duplicate that EQ plugin and add an opposite cut onto the wet track as well. So I'm boosting 10 dB at 1 kilohertz, and then I'm cutting 10 dB at 1 kilohertz, both with the same plugin in series and both with the same Q value. So theoretically, we should still have perfect silence. Both tracks are completely out of phase with each other, which will result in a total cancellation, and our EQ adjustments are mirrored, so there really should be no frequency content that's coming through the speakers, right? Everything should still be balanced. Well, let's check it out. So it's super interesting to see how the result is different with each plugin. Some cancel out perfectly while others range from tiny filtered sounds to some weird bleed going on in the low end. So it's a really cool experiment, but what's really going on here? Why is any of this actually happening? Let me know your thoughts in the comments, but here's my 2 cents. Okay, so number one, it could be something to do with phase. So whatever sound is left over could be the artifacts that are left by the EQ because it has adjusted the phase. By comparing this to the original, you can hear the phase discrepancies that the EQ is adding. So digital EQs use phase to subtract specific frequencies. These are essentially just digital delays that add or subtract frequencies using phase cancellation. They add a phase shifted version of the original to create alterations of a specific frequency band of the signal. So if you add a in-phase signal to itself, it will get greater, it'll get louder. If you add a delayed signal, phase cancellation occurs and ultimately attenuation. At least that's my understanding of it. If I'm wrong, please let me know in the comments. Or reason number 2, the plugin does not have a consistent Q curve. So often we tend to boost wider and cut more narrow, and some EQs are designed to complement this by scaling the Q value differently, allowing for more narrow cuts and much wider boosts. So for this test, it's my guess that the boost and the cut that we made would only be canceled completely if the EQ had featured consistent Q. So what we're hearing then is the difference between the two curves. Because the cut was narrower than the boost, they're not lining up to give us perfect cancellation. So to test this, I attempted to manually match the Qs of the EQ plugins that didn't completely cancel out, and I was able to adjust them until I found the quietest spot. So it's interesting examining this perspective. Remember that we're listening to the mirror image of the mix. So anything we hear would be all of the stuff that's canceled out of the mix. And that's important to know if you want to make sure that your plugins are really doing what you think that they are. So what does this tell us about the EQ that we're using? Well, for one, it might mean that the EQ doesn't have a consistent Q, and that's really not a big deal. It's not going to affect its performance. It just means that its Q increases at a different scale whether you're boosting or cutting. Second, EQ may be causing some unwanted phase cancellation. There was definitely some weirdness going on in a few of these that made me ask if there's some truth to the phase argument. The analog modeled Sheps 1073 by Waves did absolutely horrible on this test, exposing a ton of information that was well below the 1 kilohertz that we were boosting. So I'm still wondering why that happened and if that's an artifact of the phase shifting of the plugin. So again, let me know your thoughts in the comments. And it's important to remember that when people talk about analog color, it's really phase destruction used aesthetically. So, the analog EQs, they use capacitors and resistors and different components, and they work differently than digital, but they still aren't perfect. And because of that, they add like a vibe or a color to the source and alter the phase information in a specific way that we've grown to find pleasant and desirable. And it's okay that analog does this, it's okay that plugins do this, but it's important to be aware. So if you're using a really complex EQ curve, it might be doing a lot more than you're really aware of. So in closing, it's always a great idea to work smarter and figure out how to do more with less. Less processing will be less destructive, and that effect will compound across an entire mix. So it's always best to get it right at the source with a great performance and some really good microphone techniques. So if you haven't already done so, check out my book, How to Record Anything with Clarity and Character. In there, I have 4 easy questions to simplify microphone choice. It's been getting some great reviews on Amazon, and it made it to the #1 best-selling spot in Amazon's music and hot new releases category. So definitely check it out. I'll leave a link in the description below. That's all for now. Thanks for watching, and as always, make it happen.